welcome back to yet another Just 5 Mins. So we've got vectors today, and what the heck is a vector? And why is it important? A little clue, it is connected to AI as usual, that everything is at the moment. But a vector in physics, for example, is a quantity that has both magnitude and direction, which doesn't really help as much, does it? But I will put some links below. But in that sort of statement, a quantity as both magnitude and direction is not too far off what we're talking about. So we are talking about, well, a couple of things actually: text embeddings and vector databases. Oh yes, the new hotness, and they've been around for a while, but of course they're really getting a lot of visibility because of the AI advancements. Okay, so first of all, what is a vector and how is it used? Well, the context that I'm looking at the moment is to do with text embeddings. Okay, so at first I thought, okay, does it just take words or sentences and convert them to numbers? Meaning, is that ASCII or something, or does it do something like that? Of course, it isn't. It's a little bit more complicated than that. And again, it's a whole world of proper, what I would deem proper AI research, where you have to actually do the hard work, not just use some AI tools. But anyway, vector embeddings are a technique in machine learning and NLP to represent information in a format that they can be easily processed by algorithms. So again, it depends on the model, and you've probably got like things like GPT-4 and what is it? The Google ones, all the other types of models that have been used. So the way that text can be interpreted and captured, and the meanings extracted from, is all to do with text embeddings. Okay, so the idea is that you could have a sentence that will basically allow a computer to understand the meaning of those words and find similar words in large bodies of text. So when you see a sentence, it could be that you've got an array of seemingly just random numbers. Okay, but those numberings there, those text embeddings, are used then to actually look at other things and say, is this similar to that? So you can imagine, if you've got fruit, you can have an apple, an orange, etc. They're all different, but they are classed as fruit. Okay, same thing that you could theoretically do something where you've got a CV and you think, well, here's my ideal CV that I'm recruiting for. And rather than you having to go through all of that manually, you could technically feed in lots of CVs and find ones that sort of fit that pattern. That's another example. I might have to write an app for that. Anyway, but that's a different thing, isn't it? But the idea is, so those vectors are indeed numeric structures for the context. So they're not just randomly created from the ASCII values of words. Vector databases is where you're actually storing that data. Okay, and one of the main things is that it can actually give long-term memory to things like GPT, like ChatGPT, and things like of that. Okay, you've got Lambda, all the other types of models that are out there, but the idea being that you can store a lot of that history and context that you're asking. And I know things like ChatGPT in the pro version anyway will keep a history, but the idea is that you've got a situation with the vector embeddings and vector databases that will allow you to store this type of information, and it does create the closest match between things. So that's why it's different to like a relational database, because it's all to do with context, the nature of the phrasing, and all things like that. So there's some really good links to a couple of videos and whatnot, and I think I'll write a blog post about this because it is got Obviously, there's a massive depth to this. If you really want to go down the AI scientist route, then be my guest. But unfortunately, not all of us have got years to actually get this into our heads. But that's what we've got today. It's all to do with vectors, text embeddings, vector databases, and where this will end up going. But we'll see. We'll see. I'll drop some other links in below, and I'm sure this will be a topic being revisited in the future. Okay, until the next time, take care.